Hello and welcome back. This is a short video to walk us through an example of using a class in Visual Basic. I want to preface this video with just a little explanation. Um, the objectives that we have for this unit are just basically to get the idea of object-oriented programming, what a class is, what objects are, how the mechanics work. But we're not going to spend time on applying the specific syntax in Visual Basic. However, I understand that for me at least, it's very important to see this in action, to really understand and wrap our minds around how this works, how this all fits together. So I did want to show you an example of how it could be applied in Visual Basic. So I'm actually going to start over here on the right in the Solution Explorer window. Over here we see our module 1.vb, and that's actually what's opened right now. And that's our familiar main procedure code, which is what's going to execute when we hit start without debugging. But I wanted to draw your attention to the fact that we have a second file of source code file, so it's a .vb file, and it's called employee. So I'm going to double click on that and let's take a look. So as you can see, this is the definition of class employee. So how did I get here? Since this class was already created, let me show you. If you right click on the name of your project, and you say add new item, there's a lot of different items that you can add that will come up from this menu. Or you can come down here and just say class. This will allow you to create a new class, and it just basically creates an empty class for you of the given name. So for example, if I were creating class dog, it creates another file over here in Solution Explorer called dog with an empty class called public class called dog. That would enable this project to interact and create objects of type dog. So I just wanted to show you how you can create a class. I'm actually going to close out of that. We're not going to use that class. It's not going to hurt anything to have it out there, but we're going to focus instead on the class employee. Okay, so let's take a look. This actually matches up to the pseudocode example. So if you watch the previous video on creating a class in pseudocode, you understand that we are defining a blueprint of what every employee object should have. Every employee should have a last name, an hourly wage, and a weekly pay. So this is how we do it in Visual Basic. These are definitions declarations of variables, also called instance variables or fields. Notice instead of dim, we have the private access modifier telling us that these instance variables are accessible to employee and to the methods in employee, but not to any code outside of this class. In contrast, the methods set last name, set hourly wage, and a couple of these others are all public, meaning that my module1.vb, for example, and the code within it can access them. There's also a private method called calculate weekly pay down here. So calculate weekly pay is only called within this class, and we only would like to keep it that way, so we define this particular method as private. Outside of that, notice these are using all the same concepts that we used in our discussion on advanced modularization techniques in the unit before this, where we talked about defining procedures as either subs or functions. We're calling them methods now, but basically they're still just procedures that accomplish a goal. Subs will not pass anything back to their caller, where functions will. So notice our get methods that get hourly wage, get last name, and get weekly pay are all functions because they return something back. So in order to use employee, this has to exist. We first have to create it. But the interesting thing is this doesn't actually get executed when we hit run. Instead, when we start without debugging, it's going to execute our code in sub main. So sum main, again, these are the same steps we saw in the pseudocode. It creates a constant low, sets it to $9, and a constant high set to $14.65. But line 8 here is where we create an object of type employee. So in Visual Basic, the way we do that is it starts out just like any old variable declaration, dim, the name of my variable, or in this case, we're going to call it an object as, but then we use the keyword new. And what that's going to do is allocate memory and space for a new object of type employee that has all those variables and methods defined that we just saw on the previous screen. Now, after we do that, we can interact with that object by saying my gardener, the name of my object, dot, and then the method that we want to use. And for us to be able to use them, they have to be public. So here we're calling set last name to set last name to green, set hourly wage to set it to $9. Then we display the weekly pay. Again, we're calling my weekly pay right here. This is actually going to jump over get weekly pay to here and execute this block of code, which returns weekly pay, and come back to finally output this entire line. My gardener makes $9 per week. Then we update the hourly wage using set hourly wage and finally output the new hourly wage. So no big surprises when we execute this. We kind of know what data we're working with already, but we can see that we have two output statements corresponding to the two console.write lines that show the weekly pay originally based on the $9 hourly rate and the new weekly pay based on the $14.65. The interesting thing is, although I've only created one object of type employee, I can create many objects of type employee. So this would be a grand daydream for me if I had my gardener and my chef or my cook. I could create an employee of, an object of type employee and call it my chef. And my chef's set last name could be Ray. And my chef's set hourly wage. Notice, by the way, let me pause here and show you. When I type dot, this is accessing in IntelliSense all the available methods for that object type, which is really cool. So we can set the hourly wage to, well, whatever we want, $20 an hour. Now that will be allowed because in employee, there are no restrictions right now. Where are we? Set hourly wage, here we are. There are no restrictions. We could have built in some business logic here that prevents values from being set over a certain limit, but we'll go ahead and let it set to $20. And then just for fun, I could say instead of my gardener, maybe I want to say Ray, or my chef, and then I want it to say Ray. So I know that that is the last name. Instead of typing R-A-Y, I want to use practice in getting that last name from the object. So my chef dot get last name. Concatenate that with makes, and then I got to be careful with my copy paste here. It should be my chef get weekly pay per week. So here I actually invoked two different methods, get last name and get weekly pay. I wanted the data from the my chef object, so I made sure to reference that instead of my gardener. So again, here we're kind of limited in scope. We only have two objects, but just understand that once employee class is created, we could create as many objects as we want. And there's a lot of classes, predefined classes, in the .NET framework, which make interacting with databases quite easy, where we can pull large amounts of data and create multiple objects of a given type very quickly. So that's a bit outside the scope of this class, but I just want to mention it so you can understand how this could be applied on a larger scale. So let's just see our final output here. We're going to see the my gardener two statements, and we also see my chef showing that value of $800 per week.